Hey guys, so in this video I'm going to start with I'm going to continue with what I discussed in the previous video, right? So question 2 part D, and then we'll be finished with question 2, right? So I'll be making two videos today. The first video will contain question 2 part D, and then I'll make another video where I'll be discussing question number 3, right? Because question number 3 is very important and a bit long, right? So let's just start. Multivariable optimization, question 2 part D, exercise 17.3, Sydsaeter Hammond, mathematics for economic analysis, right? So question 2 part D says that question 2 part D says that fx comma y is equal to x minus 2 e to the power x square minus x 2y minus 1 e to the power y minus 2 whole square x minus 2 e to the power x square minus x 2y minus 1 into e to the power y minus 2 whole square. Subject to x lying between 0 and 2, y lying between 0 and half, right? So now let's just solve this. Let's just find the partial derivative with respect to x now. So for the partial derivative with respect to x, first of all we'll treat all of the terms containing y as a constant, right? So I can write all of the terms containing y first, and this will be e y minus 2 whole square. Now I'll be using the product rule, right, so to differentiate this term. So this will give me e x square minus x plus x minus 2 into e x square minus x into 2x minus 1, right? So if I can take this term common, ex square minus x, I'll be left with 1 plus 2x square minus x minus 4x plus 2, right? So this should be equal to 0. Now what I can do is I'll just I'll save my time. What I'll do is I'll just copy this term. Let me write this a bit clearly. Right, so what I can do is I'll just take this term and I'll copy this right in this line. Now what I'll be doing, 1 plus 2x square, so this will give me this becomes 2x square. This term becomes 2x square minus 5x plus 3. 2x square minus 5x plus 3. Let me just check. 1 plus 2x square 2x square minus x minus 4x plus 2. Yeah, so this will give me 2x square minus 5x plus 3. So can we factorize this, because this should be equal to 0, right? So can we factorize this? Oh, wait a minute. So this was already here, right? Right. Yeah. So right. So can I factorize this? 2x square minus 5x plus 3. So if I just try and factorize this, this will give me 2x square. 2 into 3 is 6, and minus 3 into minus 2 is 6. Yes. So what I can do is, I'll be using this. So minus 3x minus 2x plus 3 is equal to 0, and this will give me 2x square minus 3x plus 2. So this will give me 2. I'll be taking 2 common. I'll be taking x common. So this will give me x. So this gives me 2x minus 3 minus 1. This gives me 2x minus 3. right, which is equal to 0. So this gives me x minus 1 into 2x minus 3, which is equal to 0. Now taking this term, I'll just duplicate it. Now I'll take another time, I'll take this common, duplicate this, and this will give me another term, and I'll duplicate this further, and this will give me this term, right? A low battery, I would need to grab my charger right now. I hope you can hear me. A lot of light is coming at my face. Just give me a minute. I'm so sorry, just give me a minute. I hope this is much better, right? I hope you guys can see me. Right. So well, let me just start again. Yeah. So what I have is basically so this gives me, and I put just one more bracket here, right? So this is equal to fx. This is the partial derivative of x, right? So number of stationary points that I can find from here is so e can never be equal to 0, right? Why? Because e to the power x is only 0 at negative infinity, right? So this, and y minus 2 whole square and x square minus x, so we don't need to equate it to 0. So the stationary point that I can get from here is by equating fx is equal to 0 is y is equal to half. This will give me y is equal to half, and this will give me x is equal to 1 comma x is equal to 3 by 2, right? So I can say is the 2 points that I have, or let me just find f of y term first, and then I'll say the amount of points that I can make from all of these. So f of y gives me, if I just find the f of y, now all of the terms containing x will be written first. So this will be x minus 2 e x square minus x, and then what I'll be doing is I'll just differentiate this. So 2y minus 1 gives me 2, and this gives me ey minus 2 whole square, ey minus 2 whole square. Now this gives me 2y minus 1, e to the power y minus 2 whole square remains as it is, and then it gives me 2y minus 2, 2y minus 2, and then 1, right? So this gives me, this should be equal to 0. So now I finally get and I'll be getting e to the power y minus 2 whole square, and this will become 2 plus 2, okay, so this will become 2 into 2y minus 1 into 2y minus 2, right? So this will be basically 2 plus so if I just take 2 common, so 2 comes outside, 1 plus 2y square minus 4y minus y plus 2. So this again becomes 2y square minus 5y plus 3, right? And this was the same term, as before. If we just see here, right, this was the same term as before. So 2x square minus 5x plus 3 and 2y square minus 5y plus 3. Shall I check my calculation once more? So this gives me so this was 2 e y minus 2, 2y minus 1, e to the power y minus 2 whole square. Yeah, so 2 into y minus 2, and this becomes so if I take e to the power y minus 2 whole square outside, this gives me 2 plus 2y minus 1 into 2, and then I take 2 outside, 1 plus 2y square minus 4y minus y plus 2. Yeah, so 2y square minus 5y plus 3, right? Now finally my terms become x minus 2, or let me just duplicate this. Why shall I take up more of your time? Duplicate. 2 is in a bracket. Right, so I just put 2 in the bracket. So this is f of y. Right, so finally what I get is, if I just factorize it, I've already factorized this 2x square minus y plus 3, so this gives me x minus 1 into 2x minus 3, right? So if I just copy this term again, just duplicate this, so this gives me y minus 1 and 2y minus 3, because the expressions were same, right? So this gives me equal to 0, so f of y equal to 0, so this gives me x is equal to 2, y is equal to 1, y is equal to 3 by 2, right? Now the set of points that I can have is the set of stationary points that I can have, or let us draw set of stationary points. Let me just write this as a, so this will be 1 comma half, 1 comma half, 1 comma half, 3 by 2 comma half, 3 by 2 comma half, and it can be 2 comma 1, 2 comma 3 by 2, right? These are my set of stationary points. Now I'm already given 2 constraints also, so I need to take them into consideration. So my x lies between 0 and 2, my y lies between 0 and half. Fine, let's just draw these constraints. So my constraints given to me were this, so this is my function. Let me just open this up, let me just select all of this. Right. So I just drew a line. Now let's just draw a figure. So my ruler now goes away. Now what I can do is I can just mark, this is my origin, this is my y-axis, this is my x-axis. I am only taking the first quadrant. Why? Because my x is because my x is greater than 0 and my y is also greater than 0, right? I'm so sorry you can't see my face clearly. So much sunlight is coming out from the window, right? So just creating a distraction for me also. But anyways, you guys need to focus on this. So my x is lying between 0 and 2, so I'll be marking 2 and I'll be marking half here. After that I'll be drawing 2 lines. One line here which is y equal to half, and I'll be drawing one line here which is x equal to half. So this gives me basically 4 edges. Can you see those 4 edges? This is my first edge, this is my second edge, this is my third edge, and this is my fourth edge. I used dotted lines because it was becoming easier. Using the ruler was taking a lot of time. That's why I used the dotted lines. Otherwise these all are proper edges, right? So if I just use this pen only, I can join these. this is one of my lines. Right, so I have 4 edges now. I have to take all of these boundary edges, right, into my consideration. Earlier what I did was I took the stationary points. Now we were also given that x lies between 0 and 2 and y lies between 0 and half. We have to also see that my all of those points which give me my y being greater than half, or my x being greater than 2, or my x being less than 0, or my y being less than 0, all of these points which have x either less than 0 or x greater than half, or y less than 0 or y greater than half, all of these points are not my stationary points, right? So in my set of stationary points I can reject some of the points. Let's just do that. So this point, yes, because my x lies between 0 and 2 and my y lies between 0 and half, yes, so this point can be taken into consideration. Now this point, my x lies between 3 by 2 and my y is half, yes, this point is also feasible. It can be an interior point. And this point, my x is 2 and my y is 1, so this point is rejected. Why? Because my y lies between 0 and half. Again, this point is also rejected. Why? Because my y lies between 0 and half. So we only have 2 points left. So can I update the set of stationary points? Set of, now let me just write another set. So this is set of feasible interior stationary points, which is now B, the set B, and the only points that are qualifying here are right. So these 2 points, right? Are we clear with it? Yes. Now let's just move on. Now the 4 edges, what I can do for countering the 4 edges is I can take, let's just take the first edge. On the first edge, on this edge, I have all those points where my x lies between 0 and 2 and my y is equal to 0. Why? Because all of these points will have coordinate where all of the points lying on the first edge will have complements like x comma 0, where my x lies between 0 and 2, right? Now let me just clear this up. Now I'll be solving it for 4 cases, so I'll be just drawing these lines. First, second, third, fourth will come here. Let's just now take the first edge. I hope you guys can see. Let me just zoom. So this is edge 1. Edge 1 has all the points where y is equal to 0 and my x lies between 0 and 2. Now if I take the function and I just put in the value of y equal to 0, so this will give me f of x comma 0, right? F of x comma 0 becomes, so all of my points where my y is equal to 0, so this becomes, if I put in y equal to 0 here, this gives me e to the power 4, so x minus 2, so this becomes, so this, I need to remove these lines now. Great. So I'll be increasing the area. I'm so sorry. Right. So this gives me x minus 2 e to the power x square minus x. I hope you guys can see. And my y, 2y. So my y is 0. So this gives me minus 1 e to the power 4. Because my y is 0, so 2 minus 2 whole square is 4. Right. So this gives me this. Now I can write fx comma 0 as a function g of x. Right. So I'm just writing fx comma 0 as g of x because it has now become a single variable function. That is why I'm defining it in a single variable. I have explained all of these points previously. I am now not going to explain these points again and again why I'm writing this as a single variable function. If you have any doubts, just go on and visit my previous video. Even if you have any doubts related to extreme value theorem, I've explained it in the best possible way that I thought. If you guys want to give it a try and you want to find some kind of explanation on extreme value theorem, please go and look at my first video of multivariable optimization. It was around 50 minutes long, I think, right? Not 50 minutes, it was around 1 hour 10 minutes long. Yeah. So now let's just get back into it. So g of x now becomes x minus 2, the same function, only because it has become a single variable function, now gives me, let's just write the constants first. This gives me minus e to the power 4 x minus 2 e x square minus x. Now let's just differentiate this function. This gives me e to the power minus 4, and e to the power minus 4 comes out, right, minus e to the power 4. I am now differentiating this single variable function. So this x minus 2 gives me 1 into ex square minus x plus x minus 2 into ex square minus x, which now gives me 2x minus 1. I think we have already found this earlier. If I just show you guys, see, this was what we did earlier. The same expression coming here, the same expression coming here, the same expression coming here, right here. So now what I can do is I can directly write it as these 2 points. I'll be getting the same expression, somewhat same expression. So this gives me these points only. So x minus 1 into 2x minus 3. Now what I can do is I need to find where this function is increasing or decreasing, right? So this is x. I need to check where this g of x is increasing or decreasing, right? For that, what I can do is let me just take all of the points that can give me a stationary or critical point here. So ex square minus x can become 0 or infinity where? At x going to, it can never become 0, because if we go to infinity, x square minus x also goes to infinity, so we just don't take this expression at all. So now what I can do, what I was doing earlier was here just now was I was finding the critical points. For critical points, I need to find all of those points where my first derivative is giving me either a positive infinity, negative infinity, or it is giving me positive infinity, negative infinity isn't the correct term to explain it, where my function is not defined, or where my first derivative becomes 0, or my first derivative is not defined. At those points are known as critical points, right? So now I am just not taking x square minus x here, accounting it, right, because it is giving me positive infinity or negative infinity, and it doesn't really matter here while finding. If for example it would have become something like 1 upon x, so then I would have taken 0, because if g of g dash x was 1 upon x, so g dash x becomes not defined at x equal to 0, then I would have taken. But if I draw, while drawing a number line, we generally mark negative infinity here and positive infinity here, and when I do that, I really can't see the change in signs across infinities, right? So that is the reason why we can ignore this for now. So my 2 points that I am getting is x is equal to 1 and x is equal to 3 by 2. So 3 by 2 comes here and x comes here. Now this is negative sign, so I will be using negative, positive and negative. So x is equal to 1 is a local max, local min. Now I am not going to explain this again. I have explained this in the previous video, in the first video. So I am just clearly starting with it, and x is equal to 3 by 2 is a local max here, because the derivative is moving like this and the derivative is moving like this in the second case. Minus positive x equal to 3 by 2 and x equal to 1. So now I have 2 points, f of so this was g of x, right? So f of 1 comma 0 is equal to g of 1. I need to just check the value at 1. So f of 1 comma 0, 1 comma 0 will give me x square minus x, when x is equal to 1 is 1 minus 1 0. So this gives me 1 minus e to the power 4 and minus 1 plus e to the power 4 plus e to the power 4. plus e to the power 4 minus 1 minus positive e to the power 4 plus e to the power 4, yes. And g of 3 and f of 3 by 2 gives me 3 by 2 comma 0 gives me g of 3 by 2, which gives me g of 3 by 2 gives me if I just put in 3 by 2, so 3 by 2 f of 3 by 2 comma 0, so 3 by 2 minus 2 is 3 by 2 is 1.5, right? So half, so negative half, negative positive, positive half, so positive half e to the power 4 and e to the power so negative, and this is negative half, positive e to the power 4 and e x square minus x, so x square 9 by 4 minus 3 by 2, 9 by 4 minus 3 by 2, 2 3s are 6, so 3 by 4, oh sorry, I need to grab my charger, just give me a minute. So so half e to the power 3, so this gives me 9 by 4 minus 3 by 2 is 6, so 3 by 4, right? Yes, 9 by 4. So this gives me half e to the power 4 plus 4, so 16, 19 by 4, so 16, 19 by 4, yes, so 19 by 4. 19 by 4 and now let's just move on and check edge 2. So this was my edge 1. Now I'm going to take edge 2. So at all points at edge 2 you can see this is the edge 2. At all points on edge 2 you can see that I have x equal to 2 and y lying between 0 and half, right? So x equal to 2, edge 2, so this is edge 2, x is equal to 2 and y is lying between 0 and half. So my f of x comma y becomes, my fx comma y was this. So if I just put in x is equal to 2, let me just copy and show you. So as soon as my x becomes equal to 2 and my y is varying between 0 and half, this becomes 0. This function becomes 0. So at all points where my x is equal to 2 and my y is lying between 0 and half, I get 0. So where my y is lying between 0 and half. So we have taken care of h2. Now let us see h3. So h3 says that my x is lying between 0 and 2 and my y is equal to half. So this was h3, y is equal to half and my x is lying between 0 and 2. So whenever my y is equal to half again, my y is equal to half. So if I just copy this, so let me just write. At h3 I have y is equal to half and my x is lying between 0 and 2. So this gives me my fx comma y, which was equal to x minus 2 e to the power x square minus x, 2y minus 1 e to the power y minus 2 whole square. So at f of x comma half, this becomes, so 2 into half 1, 1 minus 1 0, so again 0, where my x is lying between 0 and 2. So now what is left is edge 4 only. So edge 4 says that all points where my y is lying between 0 and half and my x is equal to 0, right? So let's just move on to edge 4. Now moving on to edge 4, edge 4 says that here buddy, my x is equal to 0 and my y is lying between 0 and half. So fx comma y becomes fx 0 comma y, which gives me minus 2 into e to the power 0 into 2y minus 1 into e to the power y minus 2 whole square. So f of 0 comma y becomes minus 2 into 2y minus 1 e to the power y minus 2. Again this becomes a single variable function, and I can write this as h of y is 2 minus 2 into 2y minus 1 e of y minus 2 whole square. Now finding the first derivative of h of y gives me h dash y, and again this differentiating this will give me the same expression as here. This will give me the same expression, right? Let's just see here. What I did was f of y becomes this, so I'll be getting the same expression, just 2 will be outside, right? So this expression I'll be getting. Let me show you guys. This gives me 2 and this gives me e of y 2 and e of y minus 2 whole square, and this gives me plus 2y minus 1 into 2 into y minus 2 into y minus 2 into e to the power y minus 2 whole square. So my h dash y gives me, so 2 and 2 comes out common, and e to the power y minus 2 whole square also comes out common, so I'll be getting 1 plus right away this gives me 1 plus 2y minus 1 into y minus 2, 1 plus 2y minus 1, 1 plus 2y minus 1. So if I take common, 1 plus 2y minus 1 into y minus 2 into y minus 2, 2y minus 1, y minus 2, and this gives me y minus 1, 2y minus 3. Actually it's the same thing. So this gives me, this is equal to 0, so my points are 3 by 2 1, negative sign, negative, positive, negative. So y is equal to 1, local min, y is equal to 3 by 2, local max, or point of concern. If I don't even write local, it doesn't make sense to write local, because it is a boundary point and I am using my constraint with respect to the function, original function. I don't think I should be mentioning local here, but why am I saying local? Why? Because my first derivative is negative before 1 and my first derivative is becoming positive after 1, so this tells me that a shape like inverted shape like U is being formed, and here a shape like inverted U is being formed. So this tells me this can be a point of this is a point of local maximum, this is a point of local minimum. But here in our constraint, in our context, I shouldn't be saying this, but let's just leave for now. So h of 0 comma 1, so h of 1 is equal to f of 0 comma 1, which is minus 2, 2 into 1 1, so this gives me 1, minus 2 into 1 minus 2, e to the power 9, e to the power 1 minus 2, so this was 1, right? So 1 minus 2 minus 1, so e to the power 1, e to the power 1 minus 2, 2 1 1, so e minus 2 into e to the power 1 and h of minus 2 into, so 2 into 3 by 2, so this gives me 3 minus 1, and this becomes e to the power y minus 2, so e to the power 3 by 2 minus 2, so this becomes minus half whole square, so this gives me minus 4, so 2 into minus 2, so minus 4, e to the power 1 by 4. So now we have taken care of all of the points. Now let's just check the highest and the lowest values where we are getting, and we can make sure our answer pose that. So now moving on, if I just find the value of the function at the stationary points, feasible stationary points, so y is equal to 1 comma half, this is 0 because y is half, it will become 0, and whenever y is 3 by 2 comma half, again this becomes 0, right? So this is one of my points, this is one of my points, now this is one of my points, this is so now we have found all of the points, right? So I need to correct myself once. One point that I missed in this set of stationary points was 2 comma half, so 2 and half. 2 comma half was one more combination that I missed, right? So 2 comma half, I need to take one more combination, so 2 comma half, 2 comma half, so 2 comma half and 3 by 2 comma 1. Oh, I've missed a lot of other stationary points also, so let me just correct myself once. So this set is not over yet, so this set contains some other stationary points also. So 2 comma half, 2 comma half is a stationary point, 2 comma half, 2 comma half, and then 1 comma 1, 1 comma 1, and 1 comma 1 is a stationary point, and then one more stationary point is 3 by 2 comma 1, 3 by 2 comma 1, and then another stationary point will be 3 by 2 comma 3 by 2 comma 3 by 2. Now we all know only the feasible interior stationary points will be this 1 comma half, 3 by 2 comma half, 2 comma 1 will be rejected because y is belong to 0 to half. Then my 2 comma 3 by 2 rejected, 2 comma half accepted, 1 comma 1 rejected, 3 by 2 comma 1 rejected, and 3 by 2 comma 3 by 2 rejected, right? So my one more point that I need to include in my feasible points set is this this point, which is 2 comma half, right? So now my set of feasible interior stationary points has become f of 1 comma half, 3 by 2 comma half, and f of 2 comma half, which if I put 2 comma half, and this will be 2 comma half, so 2 comma half, so 2 minus 2, 0, 2 comma half is 0, this gives me 0, right? Other than that, I think I have taken into account all of the other points. and also I have another point f of 0 comma 0. F of 0 comma 0 will also be a corner point here. So when x is also 0 and y is also 0, another point that I can take here. So this will be here. So f of 0 comma 0, 2e to the power 4 will be the max, and 2 half comma 0 is again 0. This is the same point which I was talking about, right? Now in edge 4 I'll be rejecting this point because why? My y is less than half, and again rejecting y because my y is less than half. So rejecting all of these points. So I'll be rejecting all of these points. Tick mark I just put to show you guys the value that I found. So just reject all of these points, and then all of the points, these points will be accepted. These points will also be accepted on edge 2 and 3, and on edge 1. On edge 1 I have 1 comma 0 and 3 by 2 comma 0. Yes, these points can also be taken into consideration. 3 by 2 comma 0. Yes, these points can also be taken into consideration. So 0 comma 0, but 0 comma 0 gives me my max, 2 into e to the power 4, right? So e to the power 19 by 4 is approximately equal to, if I take 19 as 16, so e to the power 4, so half into e to the power 4, closest value. So is half of e to the power 19 by 4 is just slightly greater than, not greater than, is just slightly greater than half into e to the power, is slightly greater than half into e to the power 16 by 4, and half into e to the power 16 by 4 is half into e to the power 4, because 16 divided by 4 is 4, right? So this will clearly be less than 2 e to the power 4, right? So this gives me my max. Now I'm just removing all of this. Here I don't know the exact value of e to the power 19 by 4, right? That is why I'm taking approximate values. So this tells me that 0 comma 0 is giving the max. And what is my min now? The minimum the value that I can have is, all of these points are rejected. So these are rejected, and edge 3 and 2 are now telling me the min. So my min is occurring at when my x is equal to 2, and my y is lying between 0 and half. The values that I get is y is lying between 0 and half. I get f of 2 comma y as 0, and when my x is equal to, when my y is equal to half, and my x is varying between 0 and 2, I again get f of x comma half, which is equal to 0. So these points, these set of points are my min. These are my min. Or I can also say that these points also comprise of my min. And you can see 1 comma half lies between these all points, all three of these points lie in these domains only, right? On edge 2, on edge 2 and edge 3, right? You can just see x is equal to 2, and y lying between 0 and half, and y is equal to half, and x lying between 0 and 2, right? So these edges, right? So these edges are giving me 0 and 0, right? Finally, this was my answer. This was a bit tedious question. Let me show you my answer, right? So this is finally our answer, and these are my min. So if we just open up the screen, or let me just show you. Oh, wait a minute, what is this happening? So sorry. Right. So second question. Second question, part D. I'll just cut this part out. Second question, part D is maximum at 2e to the power 4. Maximum at 2e. Maximum is 2e to the power 4 at 0, 0, as I showed you guys, and then minimum 0 at x, half, where x is lying between 0 and 2, and also y is equal to 0, 2. I am not able to see the other edge here. Right. Yes. So my, and for all 2, y, where y is lying between 0 and half. Right. So our answer was correct. Thank you very much for watching this video. If you like my video, put in a comment. If you have any doubts, put in a comment. It encourages me a lot. I'll also be putting the working of this question as it will help you a lot, right? So thank you. Please share the video with your friends and do subscribe the channel. Thank you very much.